I've got this design. I didn't do all this CAD work, but I did a lot of the design and the initial prototyping. This is uh, a spooling machine. So I've got this spool of wire, and I've got this stepper that controls this little belt, and it moves my guide this way. And then here I've got something, you can see it's a little defunct, but I can have a part fixtured in here, and I can turn it and have the supply wire wherever I want, and of course the control board. But that's not the important thing. The more important thing I want to talk about is some principles that were used. Um, a few things that I want to know in no particular order. One is, check it out. This is a good idea. Uh, right, this is the power supply right here, and the power supply is being used to add rigidity to this whole design, right, and keep it nice and heavy on the bottom so it's all stable. That's a good thing. The other thing is, this is all the 3D printed parts. Well, not all, but this base is all one part. Um, it can be restrictive if you don't have a printer that can print something this big, but that is nice, right? Being able to just click print and forget about it. It's very nice. Another thing to point out is, for the most part, this isn't 100% true, but for the most part, this is material efficient. What do I mean by that? Well, right, you can see this grid right here. There's no real reason for there to be material in here, right? It just needs to exist there. So, or it just needs to have a light connection there. So adding in this grid pattern, same thing with these motors here, right? I don't really need this point because it's not using a ton of, it's not exerting a whole ton of force. Yeah, so material efficiency is another important thing. That said, I mean, there are some kind of risk zones, like these little prongs here, right? It was printed obviously flat, and so now we have these layer lines that are along this axis, and so this is prone to breakage. That's something to be aware of, but it's kind of a trade-off there. Some other things that I guess I want to talk about with this design also is, you see, right, I had a, and here I have this is a bearing, right? So I have something that will be fixed to this, and that bearing just holds the other side of the rod and allows it to spin. Get this off here real quick. Yeah. So nice camera hand. Anyways, on this bearing, this is a really hacky trick that I use from time to time. This is, no, at this point kind of old, but this is some Teflon tape that I wrapped around there, and the reason for that is I needed to add just a little bit of thickness to fit into this hole that was printed, right? There's this little spot. What would have probably been better, is to make this hole a little bit smaller, and then I'd have to post-process it using something like sandpaper or a file or nail file, something along those lines to clean that out. Because as you can see, right, I mean, there's a couple design problems. Really, I probably should use two bearings here just to have some extra stability. But it's not the best tolerance. It's an okay tolerance, because you can see. But so that's something to be considered of. Is and there's no right answer, right? What type of tolerance you're going to need is going to depend on your situation. But in this case, I probably misjudged, and I probably should have made this hole a little bit smaller, knowing that I was going to have to post-process it. But sometimes post-processing isn't an option, right? Sometimes, especially if you're mass manufacturing things, you want to have as few steps as possible. Right, and obviously another important thing is making sure your dimensions are right, right? So this was designed in OpenSCAD, and so a lot of these things were parametric. These were modules that could just be copied and moved. This grid was all parametric. But right, getting these dimensions, right, that's an important thing so I can mount this, because those are dimensions I can't change, right? I need to obey the fact that this enclosure had these holes here. So that's just something else to be considered of. I mainly just wanted to present this as a case study and highlight some of the important mechanical considerations.